Okay, we're live.
Wait, I have a question.
Go ahead.
What's the difference between number 4 and
And number what?
number 4 and number 2? What's the difference?
Well, because A is 2 for number 2, right? So that affects the amplitude. For number 4, B is 2. That's going to affect the period. So the amplitude will be 1 for number 4, but the period will change. We'll get to that very shortly. Okay, so let's look at number 3. What do you think that's going to do? Yeah.
So 0. Oh, so it's like a reflection.
Yeah, exactly. So it's going to flip over the x-axis. All right. So it flips over the x-axis. All right. Okay, Frankie, stop being weird. Even though A is -1, the amplitude would still stay as 1. Because amplitude is just a vertical distance from middle to peak. The peak will happen elsewhere, but it's still 1. All the negative does, it flips over the graph. And then B, you can think of it that way, sure. Period is 2 pi. Period is 2 pi. So you're still going to start and end the same place. 0, 2 pi, middle, pi over 2, 3 pi over 2. The amplitude is still the same. But then where we... Some of our points will be a little different, right? So instead of progressing upwards, we're going to progress downwards, right? But then we'll come back up eventually. And of course, we have this, we have this. So that's all. Very simple. By the way, notice how we're plotting at least how many points? 5 points, exactly. That's another important thing for sine graphs and cosine graphs. Always helps to plot at least 5 points for one cycle, because that way you'll be able to get the peak, be able to get the trough, and you'll get 3 of the middle points. So this completes this full cycle. So plot at least 5 points when doing these. So you have start, end, and 3 in the middle. I'm sure he does. Okay, and notice, no table. Why are you saying sick, Phil?
SRK.
Okay. So Mackenzie says hi to Sarah personally. All right. Wait, what? All right. A equals 1 and B equals 2. So now it's the reverse of number 2, where number 2, A is 2 and B is 1. A is 1 and B is 2. So the amplitude is 1. What's the period going to be? Good. Right. Yeah. This is common knowledge. You know, Phil's a little off sometimes. So, sorry, Phil. I didn't mean to call you out like that.
Phil, say Indianapolis.
Oh, I'll get him to say it. We'll find a way. All right. All right. You probably didn't pick up your voice. You gotta say it louder. But that's okay. Start x equals 0 and x equals pi, and x equals pi, because that covers one cycle. So now when you make your tick marks, now all the graphs look the same. So it's not like, okay, sine 2x is gonna have some much different shapes. It's the same shape. The challenge here is actually labeling the axes. That's more of a challenge. It's not really so much a graph. It's actually how you label the axes. So say I have 0 and pi. What's going to be right in the middle? No, pi over 2. Exactly. Because we're always chopping this up in fourths, because there's 4 intervals. So that must be pi over 4. And how about the third point? 3 pi over 4. Exactly. So that's really what I care about. So even though what 2x will do, the 2 will cause a horizontal shrink. because it's not covering as long the distance. Instead of going from 0 to 2 pi, it's going from 0 to pi. But labeling it, I think, will make that clear, even though the graph may not reflect that truly. So we'll go black. So again, you start at 0, 0, but then we progress to pi over 4, 1, then pi over 2, 0, 3 pi over 4, negative 1, and then pi 0. So that's how that looks. And I'm not sure if there's anything else I want to say about that. Yeah, I think I have for the other classes, if I didn't make a video. All right, so we're cool with sine? You know how it works? Okay, let's look at cosine now. It's not much different. Actually, this will go by pretty fast. And it kind of follows the same conventions as sine. So let's go back to the unit circle. Now, what coordinate do we use for cosine on a unit circle? X, right? So when we start at 0 radians, it's 1. Now, if I start moving along the unit circle counterclockwise, what's happening to the x coordinates? Smaller. Gets to 0 to negative 1. Now it reaches lowest points. Now it'll start getting bigger. It's still negative, but it's rising. Goes 0. Then it keeps rising until it gets back to 2 pi or a full circle. So it goes back to 1. So what that means is that cosine will not start at 0, 0. So it'll start as peak instead, exactly. Cosine. Yeah, we'll use the same values, yeah. 0, 1. Because cosine of 0 is 1. Exactly. Exactly, right. So let's make the tick marks. 0, pi over 2, pi, 3 pi over 2, 2 pi. Of course, you have 1 and negative 1. So we start there, and then let me fill out the rest of the table. What's cosine of pi over 2? And then cosine of pi is the cosine of 3 pi over 2 back to 0 and 2 pi 1. So instead of having 3 middle points, we're going to have 2 peaks, 2 middle, and a lower. So you have this. Yeah, but not really. Because the definition of parabola is set of all points equidistant from a fixed point, a fixed line. That's not the case here. So it almost looks like the sine graph, but not quite. If you compare this to the sine graph, or actually, just to make, I'll be smart about it, let's just draw a sine graph right next to it. We're at 0, pi over 2, pi, 3 pi over 2, and 2 pi. They look pretty similar. What's the only difference? Where they start. So it's almost like if you were to take the sine graph, how would you take the sine graph and make it a cosine graph? Go ahead, Cam. You shift it how much? Pi over 2 to the left, exactly. So cosine is just like sine, just shift it pi over 2 to the left. And that's why we call cosine cosine, because it's the complement of sine. Complement is when two angles add to 90 degrees. So that explains why we have that 90-degree shift. And it'll also be a little bit more clear when we do 14.3 and 14.4. But the amplitude is still the same. You know, still an amp of 1. Period's still 2 pi. Yeah, nothing else changes. And if I were to continue the graph, and I know I'm not doing a great job drawing it, but if I were to continue the graph, it'd still look the same, just that it's just shifted, that's all. And A is still 1, B is still 1, amplitude's 1, period's 2 pi. So if I did all the other things, like changing the amplitude or changing the B value, whatever, it'll change it the same way as it did the sine graph. No different. Just it starts at the peak instead, if you don't have a negative value for A. Okay, so we're cool with that? All right. Tangent kind of marches to its own beats compared to sine and cosine. That's true. It will be undefined sometimes. Exactly. You'll see. Let's talk about it. Okay. So here's what I'm going to do. I'm actually going to choose different values to plug in for x. And you'll see why I'm choosing these values. Can you stop? Thanks. So I'm going to choose different values for x. Now, why am I choosing those values? Let's go back to new circle. Now, if you think about it, tangent's undefined at negative pi over 2. Why is it undefined at negative pi over 2? Because you have negative 1 over 0, right? Also, if I go to pi over 2, it's also undefined there, right? But let's just start moving from negative pi over 2 to pi over 2, which, by the way, is the default range for inverse tan, because that covers all tangent values. And you'll see that that's what we want. We want to cover all tangent values. If I start here and start moving counterclockwise, what happens to the tangent values as I move from negative pi over 2 towards 0 in terms of radians? It gets what? It will get bigger. I mean, it's still negative, but it's getting closer and closer to 0, so it's increasing towards 0. After I pass 0, what happens again to the tangent values? They still keep increasing, right? But now they're positive until I hit over there. Now here's the other thing too. It's actually just going to keep increasing when you get towards pi over 2, because what if you took a tangent 89 degrees, like we did this before? If you did a tangent, let me switch the mode back to degrees. It's tan 89. See how it's that? If I were to tan 89.1, 89.2, 89.9, 8.9999, whatever, it gets really high, because what's happening is that when you get close to 90 degrees, what is y getting closer towards? No, y. When you get close to 90 degrees, when you get close to 90 degrees, what does y get closer towards? 1. How about x? It gets closer to 0, right? So you're doing like something close to 1, like 0.9, whatever, divided by something really small. What happens when you do that is that you're causing the fraction to get larger. Even though the numerator doesn't really get that big, the denominator gets super small, which causes the fraction to get big. Likewise over here, at negative 90 degrees, or negative pi over 2, but instead, it's now going to be a negative, large negative number. So when we plot these, we know it's undefined here and here, because you can't do 1 over 0 or negative 1 over 0. And I notice I chose pi over 4, negative pi over 4. What's the tangent negative pi over 4 going to be? Now tangent pi over 4? 1, right? So negative 1, 0, and 1. So let's plot these. And you'll see what we do about the undefined part. Here's 1. Here's negative 1. Okay. How am I going to go about plotting undefined? What would I do? So what would I draw? Well, I can't plot points. No. Well, think about when something's going towards... Good, thank you. I need to count Katie Lynn. It'd be an asymptote, because what's happening, the whole purpose of an asymptote is so that when x gets really close to that value, so basically when x approaches pi over 2, y approaches infinity. And also when x approaches negative pi over 2, y will approach negative infinity. You'll kind of explore that, like that whole like approaching limit kind of thing when you get to pre-cal and of course the calculus. But that's why we put asymptotes, because when x is getting very close to pi over 2, y will go up. And the other way when x is going towards negative pi over 2. And if we plot the points for the other locations, we have this. So do I draw a line for those 3 points, or I draw a curve?
Curve.
Yeah, don't draw a line, because then why have the asymptotes, right? So what happens is that it's going to start over here. It's going to start to turn, then keep turning, and then shoot up.
Wait, this looks like the graph is
It kind of looks like y equals x cubed, which we did last semester. Also, when we did rational functions, we did some graphs that look like this. But this is different, obviously. But we did talk about asymptotes during, I think, chapter 8. And you know, the reason why you have the asymptotes, again, when you get very close to that x value, the y value will go up or down, depending on where you're at. Now the period, see A is 1 and B is 1. How long is the cycle?
infinity.
It's basically pi. It's pi. So the period equals pi, because what's going to happen is just going to repeat itself over and over again. So it's just repetitious. You can have the same cycle all the way through. Because if I go back to the unit circle, after I pass pi over 2, and if I keep going, what's going to happen? They're going to be negative again, right? The tangent value, and then it gets back to 0, then it's going to start being positive again, and it just starts repeating itself. So that's the reason why the period's pi, because every 180 degrees, or every pi units, the tangent graph will repeat itself.
Is the amplitude in phase?
Well, here's the thing. The amplitude we don't really look at because there's really no peak. But what A does, A is going to affect the y coordinate for pi over 4 and the y coordinate for negative pi over 4. See, what if A were 2? Then what would this point become? It would be pi over 4 comma 2. So it would cause the graph to stretch, right? If A were 2, then you have to multiply the y values by 2. So then it could cause the graph to stretch. So it might look a little skinnier because it's getting vertically stretched. Trying to think if there's anything else I want to say about that. You don't really report amplitude because there's really no peak. All A does, it affects the vertical stretching of the graph. Okay, let's talk about calculator stuff and then we're all done. Okay, when you graph this, make sure the mode is set to radians. So go to mode and radians. What was that? No, I will never ask you to graph in degrees. I'll always want you to graph in radians.
So this whole section will just be radian?
Yes and no. Wait till we get to later in chapter 14. For the most part, it'll be mostly radians. But okay, we'll do sine x. So you go to y equals, type in the trig function on a graph. Before you hit graph, select zoom. And the reason why I select zoom so that you choose an appropriate window. So what window do you think we should choose, considering what we're trying to graph here? Z trig, because obviously we're graphing a trig function. Why not use Z trig? So select Z trig. Go to second format. You can turn it back on. That's probably because you're running some other program to turn it off. So you get the curve. And the reason why this is advantageous or appropriate, it makes x min equal to negative 2 pi. It makes x max, well, close to negative 2 pi, not exactly. It makes x max very close to 2 pi. And it makes your scale equal to pi over 2. So if you look at the graph, you see how that's one cycle, and then to the left of the y-axis, there's another cycle. The period's 2 pi, we expect that. The amplitude's 1. We expect that as well. And each of these units, 0, power of 2, pi, 3 power of 2, 2 pi. And you can always change the window if you feel like you need a, or you feel like, if you know you have a smaller period, longer period, and the current values for x min, x max don't work for you, you can always just hit window and change it up. Notice how x scale is 1.57, that's half of 3.14. Notice how the y min, y max is not terribly big. Why would you want one that's too big, right? You can always change if you need to. If you want to put in, like, say, negative pi, just do negative pi. You don't have to do 3.14. It knows what pi is. It doesn't quite do 2 pi. What is 2 pi as a decimal? 6.28. So it doesn't quite do it, but, you know, it's good enough. We could change that if we wanted to. Second, and then the little, like, carry symbol for exponents. Right below clear. Yeah, Phil? Yeah. That's yeah. So it's almost like an oscilloscope. I mean, that's yeah. That's like EKG. Yeah, that's a little different though. Those are not sine curves. But anyway, so that covers everything I think I needed to say about that. You guys want to say anything else? Frankie, you got nothing? You're like full of words and you're good? All right. So we're all done.